So we've got our collision or collider and some particles in this box. These this fluid in a box. This fluid is a default. If you come here to the flip object, we don't want to use that. We want to source our fluid from outside. So I'm going to delete that and then come back into OBJ, make a new geometry network, and I'm going to call this emitter, dive inside, and I select that, yeah, and I'm going to drop a tube. There we go. Maybe if we go to ghost other objects just so we can see, because I want to place a tube just above the ice cream there so that we can use it to pour the fluid or the chocolate onto the ice cream. So this at the moment is a primitive, okay, so it's not polygonal geometry at the moment, so we need to change that to polygons, add end caps, and maybe in the z-axis, so it's, you know, following the width of the ice cream. Let's drop the radius down way more than that. I'm going to do like 6. Oops, that's 6, not 0.006. And then bring the height down as well, so it's tiny. Great. And I think, yeah, let's add, so you can see there's just one polygon going the whole way across. Put that up to 8, so we got some more geometry there. So let's move it up, drop a transform. So when it's not too high up, but kind of out of view of the camera, so around its 3.2 there. Okay, great. So we've got our geometry in the correct position. If we drop a flip source, so this will actually generate the information that we need, or that flip needs to generate to source and make a fluid. Okay, so we connect that up and straight away we see nothing. So it's going to make a VDB for us. So we have a voxel size there, and the voxel size is too big at the moment. Our object is very small. So let's drop that down to 0.005. And there we go, we can see it now. Okay, I'm going to turn on the shell thickness. So that kind of inflates your object again and gives you a nice smooth border. And I'm going to bring it down to 0.2. Okay, so you can see what we're doing there. So we just got this volume, and we've kind of inflated it up a little bit. So we're creating a volume, and also we're creating particles. If you go to wireframe mode, you can see just one particle there. That's because our particle separation is too high. If I drop that down, we'll get more. So particle separation is a very important part of flip, an important parameter. And if you go into your flip object, and right at the top, we get particle separation here as well. So we got the same parameter in both. And whenever you see that, it's generally a good idea to connect them together. We want the same particle separation here and here. So I'm going to right click on here, go to copy parameter, and then select all of this. Oops. Right click, paste relative reference, and that will copy over the value. So if I drop this down, hopefully we'll see a few more particles drop in. So the particle separation is, as you can see, the lower the value, the more particles I get. And this is, you can think of it as the resolution of the simulation. So the lower the number, the more particles we get in. This is basically the kind of distance that the particles try to maintain between each other. So the more particles we have in the simulation, the more detail we get, and generally the better the simulation. However, the more particles we have, the longer the simulation times get. So it's always a case of balancing what computer power you have, the time you have to simulate, and the quality of the simulation that you want to achieve. Okay, so we'll leave it at that for the moment. We will drop that down considerably for our final version. What else? If we take a look at the jitter seed here, if I go to the timeline and press play, we don't see anything. So if we were to bring this information into Flip now, we'd get like a line of points. We'd be sourcing points from the same place every time, and this can look kind of strange. Fluid doesn't work like that. It moves around. There's all kind of turbulence. So to make that happen, we can use this jitter seed. So you can see when I move that, it changes the position. And to make this, without having to keyframe this, we just drop in $T, which stands for $time, and then as the play bar moves, we get a different value each frame. Perfect. Another thing we need to add in is, we'll leave the jitter scale at 1, it doesn't matter. Oversampling here, so I'm going to turn that on. And if you go back into the Flip sim, into your Flip solver, and then particle motion reseeding, it should be on by default. So reseeding is, as your particles are being moved around in the sim, they have velocity applied to them. You can have times where particles are kind of pulled apart and you find gaps, you find holes in the cloud of particles. And sometimes they come together and squash together, and the particle separation is violated in a way. We get inconsistencies in the density. So reseeding will try to solve this problem by adding particles where they are necessary and removing particles. You can see the threshold, and removing particles where we have too many. Okay, and then we do a similar thing in the source here. So again, if you take a look at the oversampling parameter, it's called oversampling, and here is the same. So I'm just going to copy that across. Copy that parameter, paste relative references there, so we get 1.5 in both. And the bandwidth, so that is the this is trying to reseed particles specifically at the surface. The surface of the particles of the fluid is what we will eventually render. That will generate a particle. We'll generate a polygon mesh from, and this mesh will try to find the surface of the particles. And it's very important to have a lot of particles there. And this is basically the size. If we take a look at what it says, so oversample with this number of voxels from the surface or any surface volume boundaries. If oversample at boundaries is enabled, so it's trying to. This is how far from the surface we fill with particles. All right. So I'm going to put that up to 2 in both. There. Okay, we'll leave it there for generating our emitter, and next we will actually bring it into the Flip simulation.